lesson before your test next Thursday. Oh, yes. Just a small little test next Thursday. All that we'll be doing is taking derivatives. Every imaginable way. Today we're talking about the last way that we will learn to find derivatives all year, I think. I can't think of another technique for finding the derivatives than what we've been dealing with. So today we're going to talk about the exponential function e. What do you remember about e, the number? 2.7 something, 2.78128 something or other. It's an irrational number. It's a number. What kind of problems do you remember using e in? Natural logs. So natural logs and e's are reciprocals of one another. This is what the graph, this red line is the graph of the natural log, and this blue line is the graph of the exponential function. They are reciprocals of one another. They're inverses of one another. I just wrote this information down. I don't know if it's on yours or not. Evidently it's not. The domain of natural logs, x has to be greater than 0. That's a little fun fact you're going to want to put away somewhere. The argument, this number right here, always has to be greater than 0. Did you hear what I said? The argument has to be greater than 0, not x. The argument has to be greater than 0. So if it were an x minus 3 in there, your domain would be something different than that. What is the range? The range is all real numbers. We can get any kind of real number out of a logarithmic function. And it has an asymptote at x equals 0. This is the y-axis is an asymptote for the natural log function. Well, if you look at the exponential, what do you notice about the exponential? What do you notice specifically about domain and range, that information I've got written up there? Relating it to the natural log. They're opposite. The domain of a natural log is greater than 0. The range of the exponential function is greater than 0. So the exponential function is always going to be above the x-axis. The domain is all real numbers. We can put any number into an exponential function, but we can get out any number with a logarithmic function. And the asymptote, instead of being the y-axis, the asymptote for the exponential is the x-axis. All right? So they're reverses of one another. They are inverses of one another. We learned the other day how to find the derivative of the ln. The derivative of the ln function is 1 over the argument times the derivative of the argument. The derivative of exponential is real easy. The derivative of e to the x is e to the x. The derivative is the same as the function. What's the second derivative? What's the third derivative? Every derivative of e to the x is e to the x. Now, how do you think that should change things if we have something other than x up there? What if it's e to the 3x? What do you think the derivative of that should be? Based on what we've been doing. 3e to the x. 3e to the 2x. 3e to the 3x. E to the argument times the derivative of the argument. Okay? It's pretty much the same rule. It's a chain rule again. It's e to the same argument, the power stays the same, times the derivative of that. So your correct answer would be 3e to the 3x. Those are good thoughts of it there, but we use the chain rule with it anytime it's something other than x up there. So the derivative, if you'll notice on this screen here, the derivative of e to something that's not x is e to that same something times the derivative of that something. Okay? We're not going to go through the derivation of poof how that got there. Just magically accept on faith. That's the truth there, okay? So let's look at a few problems there. E to the 5x plus 7. What's the derivative? Is it 5 or 7? Why is it 5? Yeah, the derivative of 5x is 5. So 5e to the 5x plus 7. Okay? Not too challenging. Sorry. E to the, now what on earth does this mean? E to the 7 over x. Yes, another way to think of that, very good, Nick, is the derivative with respect to x of e to the 7x to the negative 1 power. So how am I going to take the derivative of that? How am I going to take the derivative? Well, we know it's going to be e to that same power times what? Negative 7 x to the negative 2. Very good. So we could clean that up to negative 7 e to the 7 over x squared. That's probably what you would see on your multiple guess there, okay? That right there is probably what you would see on your multiple guess. So e's are real simple after we did LNs. Find the points where f has a horizontal tangent line. What does that tell you to do, Yiming? Slope is 0. How do we find the slope? Derivative. So we want to find the derivative, set it equal to 0. We've got x e to the x. Product rule. Why do you think we need to use a product rule? That's right. We've got two things being multiplied together, x and e to the x. So the derivative is first x times the derivative of the second, e to the x, plus second, e to the x, times the derivative of the first, which is just 1, so I won't write it down. So there's my derivative. Set it equal to 0. So what are we going to do now? Negative 1, is that our only answer?
I think because it's only to 1 power.
Okay, but we've got this e to the x in there. Let's do this. Let's factor out an e to the x. And what you said is not wrong, but it's best to not do it. Because I heard Claire say, let's move the e to the x to the other side. And that wouldn't be wrong, Claire over there. Okay, sorry. That wouldn't be wrong, but I'll show you in a minute why that's not a good practice to get into. So I'm going to factor out an e to the x. And e to the x times x plus 1 equals 0. Well, now this should trigger memories from Algebra 1. What does that mean? Something times something equals 0. That means either e to the x equals 0 or x plus 1 equals 0, right? Well, x plus 1 equals 0 means x equals negative 1. What about e to the x equals 0? Can we do that?
If we set x equals 0, then e becomes 1.
Yeah, if we set x equals 0, then e becomes 1. Can e to any power be 0? No. This can never happen. This can never happen, okay? So the answer, the only time we would have a horizontal tangent line is x equals negative 1. Now, how would we find the equation? This didn't ask for it. It says find the points where f has a horizontal tangent line. So points tells us what do we want for an answer? We have this for our equation. Points tells us we want x and y. So we know what x is. We just need to figure out what y is, and we're going to do that by plugging back into the equation, and we get negative e to the negative 1. That's an acceptable answer, okay? Don't pick up your calculating device and give me a decimal there. That's an acceptable answer. Negative e to the negative 1. Okay, we need to, when I put negative 1 in up here, f of negative 1 is negative 1 times e to the negative 1. So that gives me my y value down here. Because the problem asked for the points. That's the only point we have. Complicated? Ready to look at another one? Whoa, what are you going to do there? Y equals e root x. See if you can figure out a solution for that. I'll give you a minute, and then we'll come back to it. Yeah. It was easy till we got to your turn, wasn't it? Talk yourself through it. What's the derivative of e to something? Taking the derivative, it's e to some power. Well, the derivative is e to that same power times the derivative of that power. How do I take the derivative of the square root of x? It is exactly 1/2 x to the negative 1/2. Now, how are we going to write that as a fraction? E to the root x, that's in our numerator. What's in our denominator? 2 and root x in our denominator. Okay? That would be a final answer there. Do you see this? Everybody sees how to find the derivative, this part here. Now, how did I get the 2? Because I've got a 1/2 here. So think of this fraction, 1/2, I made it into the fraction of the 1/2. LNs, yes, natural logs, yes. That's a very good thing. I have yet to figure out why this happens, but after we learn natural logs, some students always want to use that rule for everything. The derivative of the natural log is 1 over the argument times the derivative of the argument. That's the only time. If you don't have an ln in the problem, you can't take the derivative by 1 over the argument times the derivative of the argument. And all of you saying, of course, that's obvious that you don't do that. Yes, there's so many rules, but somebody's going to make that mistake. E to the x minus 4, find the derivative. E to the x minus 4, find the derivative. Same thing. Because the derivative of x minus 4 is 1, so it'll be the same thing. And this is what gets confusing to some students, because the derivative is the same thing as a function. That bothers some people. Don't let it.
Put a square in it, it's still going to put forever down.
Yeah. Yes, if we've got just x plus a constant, x minus a constant out here, it's always going to be the same thing there. That's the answer. That's the derivative. It's too easy, isn't it? Because what's the derivative of x minus 4? E? Yeah. So that should be a 1 there. Is it wrong to write the times 1? No. It's just not getting you anywhere. That looks like fun. E to the x ln x. Okay. Does ln times e cancel out? What do you think? Would the square root of 2 times 2 squared cancel out?
What now?
All right, somebody just said, does e to the x times the ln of x cancel out? I assume that means, does it cancel out and give me x? Does the square root of 2 times 2 squared? So it does. So no, they can't cancel each other out. Okay, someone has said this is our answer, e to the x over x. What do you think?
It's part of it.
It's part of it. What do you mean?
Well, that's the first half of the product.
Oh, yes. We have to do product rule. Ooh, product, not product.
The second half's just the same thing.
Yeah. product rule. So it's first e to the x times derivative of second, 1 over x, plus second, ln of x, times the derivative of first, e to the x. See? Now, the derivative of e to the x is e to the x. So then we could simplify this first part, this first term, to be e to the x over x plus e to the x ln x. And do you see that continuing to take the second derivative, just don't do it, but what's the second derivative going to look like? What's going to be the second derivative of this part out here?
That's going to be that thing again, and that one's
Going to be that thing again, right? If this is our derivative now, what if I said find the second derivative? Well, the derivative of this part out here is this whole thing again. And then we just got to take the derivative of that and stick it in front of it. And then you just keep doing that. So it could really get ugly there, couldn't it? Lots of fun. For this, yes. What's that called? The thingamabob. Quotient rule. Okay. By the way, did you do your forum question last night? Okay. If you didn't, you can go ahead and do it with grace because I haven't looked at them yet. All right. These are more common to what you're going to see, I think. Something like this. This is where we get to be a little more challenging. Find the derivative. Now, when you look at that, what do you see first? Chain rule. Okay. So G prime is going to be 3 times that same thing. We don't change it. Squared. Times, what's the derivative of the, yes sir? So what do we get for the derivative of e to the negative t? E to the negative t? I'm just asking. Should times the derivative of negative t, shouldn't it be negative there? E to the negative t times the negative, so I'm just writing that negative there, okay? Okay, look at what we've done. We've done the chain rule and said 3, this thing to the second power. Now, what's the derivative of e to the negative t? It's e to the negative t times the derivative of negative t. Yes. Times the derivative of negative t, which is negative 1, plus, what's the derivative of e to the t? E to the t. So we can make this 3 e to the negative t plus e to the t squared, not 2, there. That's a squared there. That's a t there and squared on the, yes, that's hard to say. Okay, let me see if I can say that. That's 3 e to the negative t plus e to the t. That's what's inside the parentheses, the whole quantity squared. Times negative e to the negative t. That's just moving this negative 1 back in front, plus e to the t. Can I do anything else with that? No. Why can't I just say this is e to the negative t, e to the t cubed? It's not the exact same there. Very good. Why can't I just factor that negative out and make it the same? Because then this becomes negative. So it's not going to be the same no matter what there, okay? LNs and E's in the same problem again. Really? Is that possible? Apparently, yes. Struggle through that for a second. Struggle with that one and see what you can come up with. It's a fun struggle. We do, yeah. Challenging struggle. Maybe that's a better way to look at it. Because there's different types of struggle. I mean, would you agree with that? What do you got to use here? 1 over argument times the derivative of the argument, okay? Because the ln is outside function here. So you've got 1 over the argument. 1 over the argument times the derivative of the argument. The derivative of 1 is, what's the derivative of e to the 2x? 2e to the 2x. How would we clean that up? Very good, Jonah. Very good. All right. On top of things there. Good question. Can we cancel the e to the 2x's? We've got this addition here. We can't cancel those out, okay? So there would be our final answer here. Well, this is a fun problem. It cleans up nicely, I promise you. Very good. We've got to use the quotient rule here, class. Got to use the quotient rule. Must use the quotient rule. So see what you can come up with there. I think it cleans nicely. Did I do that right? All right, good. So, now what do we need to do from here? We could distribute what? Distribute the minus through this parentheses here, okay? Are you going to distribute this e to the x over there? And if you are, what are you going to get? Don't do that, why not? It looks ugly then. Well, but we got to clean it up more because that answer's not on our multiple guess there. So if we're not going to distribute that through, what do you think? What else do you see that we can do? Okay. Well, some of y'all want to distribute it. That's fine. Well, when I multiply e to the x times e to the x, what do I get? Oh, I heard 2e to the x, e to the 2x, and e to the x squared. One of you is right. She says it's e to the 2x. Very good. You add the exponents, don't you? And if we add the exponents, x plus x is 2x. Good job, ladies. Good job. E to the 2x minus e to the x. Would you agree? That doesn't sound good, does it? Now, be careful back here. Why do I say be careful on the back end? I've got to distribute two things, people. I've got to distribute a minus sign and an e to the x. Minus e to the 2x. Minus e to the x, right? Wow. Am I going to square out this bottom? No, just leave it like that because a wise man once said leave it like that. Well, that answer's not there. Very good. We can cancel these e to the 2x's. So I'm going to have e to the x minus 1 quantity squared on the bottom. On the top, negative 2e to the x. Do you see how many places there are you can make mistakes in that problem? I mean, because you could have messed up by distributing here and saying that was e to the x squared. And you could have messed up when you added these and said that was e to the x squared. There's lots of places you could make mistakes. But if you really understand mathematics, that's a beautiful problem. That's a beautiful problem there. Okay, just a few more problems and then I'll turn you loose to do some on your own here. What do we do here? Cry? Not going to help a lot. Product rule. Do you want to distribute? Or just do product rule just like it is? Go for product rule then. I don't know. If we distribute, what do we have to do? If we distribute, how are we going to take the derivative? Product rule twice, aren't we? So we can either do the product rule once like it is, or distribute it and do the product rule twice. We're going to wind up, you're going to wind up doing the product rule. So just decide how you want to do it there. I would do it just like it is, I think. First,
teachers, please pardon the interruption. Any student, high school student government reps who are available, please come to my office. Any high school student government reps who are available, please come to my office. Thank you.
first times the derivative of sine. Derivative of sine is cosine, derivative of cosine is minus sine, plus second times the derivative of the first. Wow. That answer's not on a multiple guess. Yeah, Kelsey said I didn't think so. So what are we going to do now? Let's distribute, all right? Afterwards, we'll be able to cancel the sign. You need to distribute because once you distribute, I think you'll see some stuff that'll cancel. E to the x cosine x minus e to the x sine x plus e to the x sine x plus e to the x cosine x. So that's just distributing the e to the x through there. Is everybody with me there? All right. So now I can cancel that. The two that have sine x in them will go away. And I've got ex cosine x plus ex cosine x. So that's 2ex cosine x. And that answer's there. How about that? Wasn't that nice? No, see, if you'll just jump in, a lot of times it's not nearly as scary. Yeah. All right, I want to look at one more problem here. Oh, I want to look at two more problems. One I'm just going to talk about here. Are you going to do that the easy way or the hard way? Okay. Probably the hard way. That would be my thought as to how you're going to do it. But let's see if you can figure out how to do it the easy way. Properties? Can we? Is this the same as that? It's using the properties of logs, isn't it? It's using the properties of logs. I don't see any reason why you can't do that. What did I do here? I just used the log properties, didn't I? I took this exponent down in front and said x squared ln of e. No. If we had this, then we couldn't use log properties. But see, the argument is raised to an exponent. If the argument has an exponent in it, we can take the exponent out in front. And I see no reason that we couldn't do that there. Okay, you could do that. I'm looking for an easier way to do that, okay? Because let's chase this for a second. If we did this, what would happen? ln e is 1, so we just get y equals x squared. So what's y prime? 2x. Now let's do it right quick without doing that. Yes, ln of e is 1. Let's do it without doing that. Like Jamie said, it would be 1 over the argument, right, times the derivative of the argument. What's the derivative of e to the x squared? What's the derivative? Keep going. Yep. It's the derivative of e to the x squared is e to the x squared times 2x, right? All right. Can I clean that up any? Okay, let's go back because some of you got lost there, okay? I'm taking the derivative just using my rule for derivative for ln. It says 1 over the argument times the derivative of the argument. What's the derivative of e to the x squared? E to the x squared times 2x. Now, if I did that, then I say, well, wait a minute, I got an e to the x squared in the bottom. I got an e to the x squared in the top. I can cancel those puppies out. What am I left with? 2x. So there would have been nothing wrong with us doing what we did to begin with there. Anytime you've got ln of e, that part is 1. You can move the power down and simplify your life. Good question. When can I not move the power down? If I had the ln of e x squared. Notice the power. What's being raised to the x squared power? The whole thing on the inside. What's being raised to the x squared power in the original problem? Just the e, okay? Now, just to blow your mind, how do I do that one? Bingo, Kelsey is exactly right. You've got to have dy dx's in there, okay? So you've got to do product rule. So let's walk through this. Product rule is going to be what? First, what's the derivative of second? E to the y dy over dx. Remember, the derivative of e to a power is e to that same power times the derivative of that power. Yeah. Well, you could even think of it then because what's the derivative of x? 1. So it's e to the y dy dx minus what? 10 plus 3 dy dx. Oh, we didn't finish the product rule. You're right. We didn't finish the product rule. So how can I do this? There, look at there. So this is first derivative of second plus second derivative of first. All of this came from the first term there. Now how, because y'all are still struggling with this a little bit, how do I solve for dy dx here? Very good. If it doesn't, every term that doesn't have a dy dx in it, namely this one and this one, need to move to the other side. So I'm going to say x e to the y dy over dx plus 3 dy over dx. I'm going to move the negative 10 over and it'll be 10. I'll move the positive e to the y over and it'll become negative e to the y. Now, I take out a dy dx, factor out a dy dx. However you want to think of that. I'm going to take out a dy over dx. And I get x e to the y plus 3. And now how do I get dy over dx by its lonesome? Divide. Dy over dx equals 10 minus e to the y over x e to the y plus 3. That answer's there. All right. Now, there's no more learning before the next test. You have a forum that was due last night. You have an FRQ due tomorrow. We will have an in-class quiz, in-class worksheet, in-class pretest, whatever you want to call it. It's going down for a daily grade next Tuesday. There'll be 8 or 9 problems similar to what you're going to see on the test Thursday. I want to give it to you in a sit-down environment, see how freaked out you get, okay? Be able to give you some feedback on Wednesday. You have a web assign due Monday night. You have 3 FRQs due next Friday. Okay, so you've got several things you can do. You have 2 hours with me tomorrow, and you have no more teaching going on. So you've got approximately 15 minutes to play with something now, and then the time is yours. I do recommend you look at the web assign before Monday, because guess what? We don't meet on Monday, okay? If you wait till Monday to look at it, you're going to freak out. You're going to panic. All right. The time is yours, people.